Hello, all. Good morning and good afternoon to all of you, and welcome me all to this talk. My name is Harsha. I operate as head of AI and machine learning practice as a part of Merck Group, which is a healthcare life science company based out of Amsterdam, Germany. And the topic I have for today is how do we democratize the whole topic of generative AI at a scale for large enterprises like ours? And what has been our strategy to ensure that we can enable our businesses to build GenAI applications on a self-serve basis. And before we get into the details, let me start with what is Merck. So we are headquartered, as I already told you, we are headquartered in Darmstadt in Germany, and in US and Canada, we are operating as under the umbrella of EMD, Serono, and EMD Life Sciences. And we are into three areas of business. That is healthcare, life science, and electronics. In healthcare, we produce medicinal products and medical devices, and we focus on critical areas like oncology, immunology, immuno-oncology, fertility, and so on, mostly responsible for improving the life of patients suffering from some of these critical indications. In life science, we are a B2B business. There we focus on catering the needs of other life science companies, diagnostic, other pharma biotech companies by offering small molecule chemicals, also lab equipments and laboratory devices, and so on. And in the electronics domain, as name says, we are again a B2B business where we are catering the needs of other electronic companies. For example, we are into supply of liquid crystals, which run in the background of display materials, display devices, and we are also in the semiconductor business as well. So in this way, we have three verticals of businesses catering three different markets. When it comes to the whole topic of AI or generative AI, I'm sure that you would not be surprised that we are right now living in the whole very good times of GenAI being in practice. And as per some of the predictions, and if you look at some of the market estimations, let's say about before the whole hype of GenAI started, before the release of ChatGPT, the market size prediction for 2030 was supposed to be somewhere around $200 billion. But now, in the last a year or so, if you look at some of the market predictions, we see that the 2020-2030 market has been estimated to be the size of approximately $1.3 trillion, which is almost six times bigger than what it used to be about 2 to 3 years before. And there have been a couple of very interesting reports from Databricks. I'm just giving one reference here. It says that since November 2022, that is the launch of ChatGPT, there has been approximately 1,310% increase in companies trying to leverage different GenAI SaaS solutions. So, for example, be it OpenAI-based solutions, Azure OpenAI, Amazon-based services, and so on. Similarly, there has been at least 49% increase in the Python libraries being used that are more related to the data science, right? AI, GenAI, and so on. So this gives us a very strong indication saying that how the GenAI has been kicking off very well in the market since last 1 to 2 years. And when it comes to the AI at Merck, we don't speak about AI, but we speak about data and AI at Merck because we strongly believe that the data forms the strong foundation, right, for having any kind of AI solution to work at scale. And not having the right data in the right shape and format doesn't help to build any kind of AI applications on top of it. So therefore, our data and AI strategy at Merck has three main verticals. One is the people perspective. We look at it from the ways of working, from the process perspective, and most importantly, the technology perspective as well. When it comes to the people perspective, it's all about ensuring that the people or the colleagues in the organization understand how valuable it is important to have a good understanding of how to maintain the data, how do you create the data, understanding the basics and the grassroots approach of having the right data in the right shape and format. And it can go to extent of having helping people understand what is generative AI in a nutshell and what can it do for the businesses and what can it do for the enterprises. So we try to cover the end-to-end spectrum, ensuring that the people in the organization understands the value of our data and the value of how GenAI can bring additional value on top of the data as well. The second pillar, that is the ways of working. Here we operate in a so-called as a hub and spoke model, where we have a centralized hub that is basically our group, responsible to offer a centralized technologies and a centralized governance, centralized compliance, so on. And then we have the spokes embedded within different business units, they're embedded within different functions, who have a very strong understanding of the business processes within their departments, within their teams, and who can make use of the centralized technology and centralized practices for their use case development or for their specific solution development. We strongly work within SAFE framework, Scale Agile framework, and thanks to the SAFE framework, that is giving us a platform to ensure that we are able to have a good oversight and we can onboard different teams within the organization who can work collaboratively to make the solution successful for the whole organization. And last piece, important one, is the technology part, where we have an end-to-end ecosystem. We call it as with the name Optimize, and that focuses on very foundational level, starting from a standardized way for ingesting the data, standardized way for storing the data, how do we do the transformations, how do we build any kind of analytics, how do we ensure there is a traceability of the data applications that are built using this data. And it can also go to a level of what kind of generative AI applications have been built, and then how do we even monitor this application? How do we ensure there is a proper responsibility, governance, ownership, right? Any kind of compliance being covered as well. So this is the three ways of how we look at data and AI at Merck with a more holistic approach. And when it comes to the execution of a generative AI strategy at Merck, we see there are three layers of adoption. And this also goes in line with how Gartner also defines the GenAI applications in industries as well. So we call it as GenAI at scale, which is the most bottom line of the pyramid. So there is a very high adoption. It's mostly GenAI used for the day-to-day work, day-to-day productivity kind of purposes. And then the next layer is about embedded AI or maybe even standalone AI applications. So this can be, some examples could include Salesforce Einstein as an example, like SAP is coming up with the Joule as an example. So these are some of the examples where we have the standard commodity applications in the market, enterprise applications, and then they come with their own, let's say, AI capabilities, which can be easily used and embedded without requiring any kind of additional change on top of it. And then comes this last layer, the tip of the pyramid. And this is something we call it as a game-changing AI or a state-of-the-art AI. So this mostly constitutes highly fine-tuned models that have been built for very specific purposes that cannot be easily achieved through any kind of embedded AI applications or day-to-day AI applications. And this is something where we see a kind of more game-changing kind of work happening, for example, where there could be a major breakthroughs happening by use of an AI as well. And if you look at it more from a cost, risk, impact, and adoption perspective, right, it always goes bottom up, where the day-to-day AI applications comes at a lower risk, probably a lower cost, and maybe the impact may not be so high because it's more productivity kind of boosting purposes there. On the other hand, if you look at the adoption, definitely the bottom of the pyramid has a way more higher adoption than in comparison to the tip of the pyramid, where we may not have many teams or many groups who can go to a certain level of extent of building that kind of disruptive or game-changing solutions as such. So our strategy for democratizing the GenAI is in two ways. So we focus on two categories of internal users or customers. One are the consumers of GenAI who are probably less technical, but they rather want to be more quick in terms of adoption, and we should be able to make the GenAI easily adoptable for their day-to-day work. That's where we have a so-called as a MyGPT suite, and we do have a lot of interesting articles on the internet as well, a couple of press releases available online, where we show what kind of strategy we have been taking to release the MyGPT suite. So this is more, it's more a clone of how the ChatGPT works, and it offers basic functionalities for all the users within the organization who can use GenAI for multiple type of day-to-day purposes. On the other hand, we also don't want to completely give away the other community. This is the developers community, where we have an environment, and we call it the self-serve AI ML environment, and typically more meant for citizen developers and expert developers who wants to build more complex or highly customized AI applications for their specific requirement. So we have, let's say, two offerings. One is the more focusing on the consumers, day-to-day users, where we have several thousands of users using the GenAI applications on a day-to-day basis. And then for developers who can create those highly customized, complex applications on a specific need basis. So when it comes to the generative AI, the MyGPT suite at Merck, we have approximately 24,000 users. So this means almost 50% of our organization has been able to leverage MyGPT suite. We have approximately 4,000 assistants being built. So assistants means these are highly purpose-driven or focused, let's say, chatbots that are being built using specific enterprise data, be it documents within SharePoints, for example, in any kind of OneDrives and so on, that are highly specialized for a specific, let's say, business processes, for instance. We have been seeing a good amount of transactions every month, about 250,000 transactions happening every month, about 4 to 6% increase in the usage month-on-month basis, 4 to 6% increase in the users, as well as 4 to 6% increase in the usage. This means consumption happening. And we also see a very widespread adoption, 50 plus countries, with US and Europe being majority of the users. And of course, we have India, who's next, the third one in the list, operating at 8% of the user base. When it comes to the nitty-gritties of the specifics of the MyGPT suite, some of the functionalities we offer is it offers a collaborative building of chatbots. For example, you can have, we have a concept of groups, for example, that people can create their conversational AI applications, and they can share any kind of best practices. They can share the prompts. They can share any kind of responses coming out of some of the large language models. We also offer functionality where people can upload documents, they can upload files, different formats, including scanned documents, and also they can point to any kind of websites, be it external websites or be it internal websites, so that you can quickly build any kind of conversational applications using the data present on the web as well. We have a prompt library, which is providing some highly curated prompts where people can repurpose some of the ideas and thoughts from different colleagues so that you don't have to reinvent the wheel, but you can repurpose some of the good prompt engineering practices as well. Then we have assistants, as I told you in the previous slide. These are highly customized chatbots built for specific purposes on a specific type of data. And then, of course, then we have different categories of large language models offered by Amazon Web Services or offered through Azure OpenAI as well. So this kind of constitute the whole end-to-end capabilities that we offer to the consumers of the MyGPT suite. Then if I look at the different types of applications of MyGPT, right, on a very, very high level, we can say there are almost three types of applications. One are more creative tasks where you want to generate the contents, be it generate marketing materials, be it generating any kind of newsletters. You want to generate product descriptions, generating code, for example, for developers, translation, and so on, right? So this is, let's say, one type of applications where there is more creativity that is typically being required, and you want to use GenAI or any kind of AI/ML technologies in the background to help you with this creativity boosting. The second type of applications that we see are more synthesis in nature, where you have big, large documents, and you want to be able to extract information from these documents. You want to extract information from the websites, or you want to do any kind of question answering on top of your data, right? So this is the second category of use cases that we see, where there is a lot of synthesis of information happening that are present within documents, be it websites, and so on. And the last kind of use cases that we see are typically more embedded into automating the processes, you can say. For example, any kind of RPA tools, RPA solutions, robotic process automation, I'm going to say, right? They use GenAI APIs as an example, where they want to automate the processes and they would rather want to have GenAI either doing composing work, any kind of authoring work, for example, or maybe any kind of analysis. So on a very high level, as I said, three types of applications that we see, typically one based on very creative tasks, one very much synthesis, question answering kind of tasks, and the third one being more of an automation where a day-to-day work is kind of end-to-end automated in complementation with an RPA solution as well. So when it comes to the self-serve advanced use cases, right, typically that are meant for developers, so we have several examples. So we have almost 250 applications that are being built, and about one third are running in production. So this means close to 100 plus applications are already running in production. And these applications are typically built for very specific purposes. Now, for example, we have solutions that are built to find answers, find information from regulatory information records. Colleagues in healthcare, for example, so they have built an application that is doing more document content authoring for medical domain, for regulatory domains. Colleagues in legal, for example, they use a custom built GPT model that is then used for any kind of question answering from legal documents, contracts, and so on. So these are some of the examples of providing where applications are built by the developers or by the citizen developers, and they are then made available to the respective consumers. But again, focusing on a very edge or very specific application types or use cases. We see several millions of transactions happening for every month and almost 5 to 7%, almost month on month increase in adoption as well. So in this way, we try to now have support both the communities and consumers are also getting benefited through my GPT suite, which is a fully ready-made tool available for consumption by non-technical users. And then we have enrollment, for example, which is then supporting the developers and the technical community to build applications that are highly customized for specific business problems or purposes. If you look at the different types of applications that are being built with, let's say, with LLMs as such, we see that most of the applications typically fall into the category of retrieval augmented generation, that is, building document chatbots or building website chatbots, and so on. And on a rule of thumb, on the paper, RAG applications are easy because it sounds like it's mostly about having the data, preprocessing the data, embedding them, storing the vectors, and you want to have some kind of LLM which is now able to retrieve the right chunks of information from the documents based on the user questions, and then you're able to kind of synthesize or generate the answer, right? That is in more human readable, friendly way. That's typically it looks like, but RAG applications typically comes with a lot of challenges. For example, there can be challenges with respect to the data quality of the source data. There can be complex tables, there can be complex images, for example. There can be highly domain specific knowledge like chemistry, chemical information, could be formulas, so on. Multimodality can also be a challenge sometimes. So this is something that we typically face. So it's often easy for somebody to start building up a RAG application, but we typically see that sooner or later we start hitting more the dead ends where a simple RAG concept doesn't necessarily work for all of use cases. And there are a lot of mitigations that are available. So, for example, one can apply highly specialized pre-processing. For example, you may want to do a specific OCR by using a highly specialized OCR engines. One may want to fine-tune embedding models, or one may want to do a query optimization. For example, one may want to re-ranking, you want to implement hybrid strategy, and so on and so forth. So that is what we typically see is that most of our applications get started off very easily because it's all about embedding, storing the embeddings and building an LLM based answering a question answering system. But eventually we start seeing that it's more of a funnel concept now, right? A lot of RAG applications get started off, but eventually they start seeing the dead end because traditional RAG doesn't work. And there is a need for building highly specialized RAG applications by using specific pre-processing, by using specific type of embeddings, fine-tuning, optimization, and so on and so forth. So that is where what we do is we have been now working on a concept of advanced assistants. So we have a simple assistants where people can upload documents, files, you can point to a specific websites on the internet or internally, and you can build a quick chatbot. But that's more a black box approach. Then we also offer an advanced assistant concepts where people can go beyond a traditional RAG kind of approaches, where we offer an environment for the end users where they can build their own custom APIs. And within the APIs, the users can define what kind of flow they want to offer. Now, for example, what kind of pre-processing of the data has to be done. Do you also want to have any kind of agents that is also doing a text to SQL queries? You may want to do a Sparkle queries against a knowledge base or graph databases. You may want to have some kind of a web agent which is able to fetch specific information from the websites and so on. So that's how we try to now balance how people can find answers within the documents, within the data by using a simple assistance, but more a black box approach. It may work, it may not work. It's more a rule of thumb depending on how complex the data is and the requirements of the use cases. Then we have a second category of applications, advanced assistants, where we offer the choice where people can build their own APIs. And these APIs can eventually then be used to do highly customized pre-processing, post-processing, connectivity to the third-party systems, right? Traditional RDBMS systems, graph databases, and so on, so that you can get that benefit out of limitations coming out of the traditional rack kind of applications. So the from a technology point of view, we have a pretty modular stack in place where every component is offered as an independent service, and the developers or the citizen developers can choose and they can decide what technology or what sort of technologies can be used for their specific use cases. As an example, we offer an API environment where people can, where we have a mix of self-hosted LLM APIs, for example, Hugging Face models. We also offer third-party SaaS APIs, for example, Azure, let's say OpenAI services, Bedrock services coming from AWS as an example, models coming from Anthropic, models coming from multiple cloud providers. All this is made available within one centralized place where you have access to the SaaS APIs as well as the self-hosted models internally as well. Then we have a vector database that is typically used to build up any kind of semantic search or any kind of conversational applications. We also have an observability tool where people can do tracing, monitoring, evaluation of any applications that are being built using the large language models. In order to improve the time to the market, we also have a so-called as an application template library, where we take some of the commonly built type of applications, like RAG applications, text to SQL applications, or maybe text to SPARQL kind of applications, right? And then we kind of provide a template that can easily be reused and repurposed by developers to build their LLM applications with speed. So instead of reinventing the wheel, instead of trying to evaluate multiple available solutions in the market, you know exactly what kind of tools, libraries would best fit my use case. So you have a kind of a fair starting point instead of starting from scratch. So that's the whole objective of offering this application templates. And then most importantly, we also offer a lot of self-help guides, upskilling programs, where we try to now target different types of communities. We see like a rule of thumb is like 70, 20, and 10 as an example. So 70% more beginners who are trying to learn and get used to the whole world of GenAI, about 20% who are more intermediate users, you can say they have intermediate understanding of what LLM means, what GenAI means, and then 10% who are fairly good in this whole space. For example, you can categorize them as experts now, or maybe more pros, for instance. So what we do is that we ensure that we offer different kind of trainings and upskilling programs for all the three communities so that they can benefit the best of all the tooling and all the services that we offer centrally so that they can be faster in terms of building the solutions and making their applications go to the market as quickly and as smoothly as possible. So just a quick overview of the entire feature stack that we have. The entire stack is operating within the Elastic Container Services of Amazon, of AWS. There is an auto scaling happening, for example. So this means we automatically scale up and down, horizontally, vertically, depending on how the requests are coming from different clients. As an example, infrastructure as a code, so that we are able to deploy the infrastructure in a more semi-automated fashion. There is a centralized token-based authentication where we offer a centralized way of how people can authenticate when they want to use any kind of APIs. If there is a need for doing a batch processing, so if there are like hundreds of thousands or even millions of records that has to be processed, so these synchronous calls are not typically a best approach. So that's where we use a Kafka-based service coming from AWS, where we offer a queuing mechanism where people can submit their jobs to the queue and they can fetch the results from the queue after a stipulated period of time. So that helps in taking away that computational burden from clients, and they can rather use a queuing mechanism, especially for large batch jobs. The whole environment is secure. So when we connect to a third-party services, be it Azure OpenAI or be it Bedrock and so on, we typically go for a VPC link approach where there is a highly secure point-to-point connection happening from our infrastructure to a third-party infrastructure. encryption, we have centralized license management, we do a cost monitoring, consumption monitoring centrally. We also offer a traceability as well, where we do the traceability from our side in terms of what use cases, what applications are using our services. We also offer a traceability as a service to the customers as well, where they can also trace how their applications are being performed, how it's performing, and how it's also being consumed by the end users of their applications as well. And of course, then we also have a very good, very well defined centralized process for any kind of a legal and data privacy consulting if required. For example, if somebody wants to build an external facing application with large language models, anything that comes around copyrights, how do we deal with copyrights of the data? How do we deal with personal identifiable information? How do we deal with GDPR? When such kind of question comes, we also have a well-defined process in place where colleagues within the organization can get a right level of consulting from the colleagues from legal or from data privacy so that they know what's the best solution for any kind of problem statement they have been struck in, especially from a legal compliance privacy point of view. Yeah, so this constitutes the end-to-end, like how we are able to now build GenAI-based internal products within our organization, both focusing on the consumers as well as focusing on the developers, and then how we have set up an end-to-end framework or a process to be able to leverage the services with a scale, and you can be more successful with respect to developing your applications or use cases for any specific business problems. With this, I thank you very much for your time listening today. And if you have any questions, any feedback, I'm available on LinkedIn, so feel free to connect with me and you can ask me any questions offline as well. Thank you so much.